Okay, so we are looking at section 5.5, multiple angle and product to sum formulas. The learning objective, which you do not need to write down, to use multiple angle formulas, half angle formulas, product to sum formulas, and sum to product formulas to evaluate trig functions and to rewrite real-life models. All right, there are 4 other categories of trig identities that we have not, looked at yet. And they are of these forms. Multiple angles, like sine of some number times u, like sine of 2u, sine of 3u, or whatever it is. Squares of trig functions, there are some identities for that we have not looked at. Half angle formulas, like cosine of u over 2. And products of trig functions, like sine of u times cosine of v. All right? You don't need to write that down. Okay, so let me ask you this. Is the sine of 2x equal to 2 times the sine of x?
No.
Plus
You suggested it. No.
Yeah,
It's not.
I suggest it's usually false.
Yeah.
Okay, let's prove that it does not work. Let's pick, for example, let's say pi over 6 as my x. So if I use pi over 6 as my x, is the sine of 2 times pi over 6 equal to 2 times the sine of pi over 6? Well, what is the sine of pi over 6?
That would be about
No.
So I would have
No, you wouldn't have.
sine of pi over 6 is 1/2, isn't it?
Yeah.
So I've got 2 times 1/2, so on the right side of my equation I have 1. And what is 2 times the pi over 6? That's pi over 3.
Oh, yeah.
And what's the sine of pi over 3?
That'd be 3 over 2.
Square root of 3 over 2. And is square root of 3 over 2 equal to 1? No. So that's why this does not work. You can't just say, oh, I'm going to pull that 2 out front. That does not work. There are special formulas for the sine of 2u. The sine of 2u is equal to 2 times the sine of u times cosine u. All right?
Should we write that one down?
Yes, you should write that one down. The sine of 2u is equal to sine of 2u is equal to 2 sine u cosine u. And let's talk for a minute, just so you're like, well, where'd that come from? Who made that up? Let's actually verify this one for a moment. So if I want to show that the sine of 2u is equal to 2 sine u cosine u, I'll say verify. Right? Andrew, can you stop talking? So you can think of 2u here as u plus u, right? And then you can use our first formula from section 5.4, just using u as u and u also as v. You with me? So I'm going to write this as sine u cosine v, but my v is actually u, plus cosine u times sine of v, but my v was also u. Does that make sense? And I'm trying to show that this is equal to 2 sine u cosine u. You see how we're going to get that? I got a sine u cosine u. I got another sine u cosine u. So I really do get 2 sine u cosine u on the left, and it matches the 2 sine u cosine u on the right. So I just wanted to go through this, just so you know I'm not making up these formulas. We really could verify all of them. We're not going to verify all of them, but we could. All right, thank you. Thanks for the trust. Okay, so getting back here. So there's the formula for sine of 2u. Here are, oh, thank you. Here is cosine of 2u. Actually has 3 different formulas. The first one is cosine squared minus sine squared, and I think you can see where this one would come from. That's coming from this third property over here. If I made u and v both u's, I would have cosine u, which is cosine squared, minus sine u, which is minus sine. You see where that one's coming from? Okay? But since we have identities that you memorized for cosine squared and sine squared, that means we could rewrite cosine squared as 1 minus sine squared. Well, that's this one. And then I have 1 minus 2 sine squared. Or I could rewrite sine squared as 1 minus cosine squared, and I would end up with 2 cosine squared u minus 1. So I really have 3 different formulas for cosine of 2u. Right? And they come in handy, you know, you might want to use one rather than another in some of the problems that we're going to do. There is also, excuse me, there is also a formula for tangent of 2u. That's 2 times the tangent of u over 1 minus tangent squared u. All right, let's take a look at this first example. This is on your gift. So cosine of 2...
Whoa, you go back.
Go back. These are all in your book. Cosine of 2x plus cosine x equals 0. As a matter of fact, if you're done with your posters, can you bring them up and just put them up somewhere on the wall? Put your, use a magnet.
What room would we ever need to?
Okay, so if we are going to solve cosine of 2x plus cosine x, can we use a formula for cosine 2x?
Yes, yeah.
Which formula out of the 3 do you think would be handiest to use? First
2
one,
cosine.
second one, third one.
Second,
Why the second one, Alex?
because I have cosine.
All right, because it has only cosine. All right, so let's rewrite this right here as 2 cosine squared x minus 1. Right, that's from our double angle formula for cosine. And then I have plus cosine x equals 0. And I'm trying to solve this equation. What do you think the next step would be?
Next, oh,
All right, so we're going to factor. Let's put everything in order here. So I want 2 cosine squared x plus cosine x minus 1 equals 0. Then, do I use product sum, or can you just guess and check? Product sum. Okay. Product is 2 times the negative 1, so that's a negative 2. Sum is 1. So the 2 numbers that I would want are negative 2 and 1.
no,
2 and
2
negative
and
1.
1.
Positive 2 and a negative 1. Okay, so that means that I really want to take out this 1 cosine x and replace it with a 2, with a 2 cosine x and a negative 1 cosine x. Agreed? So we'll have 2 cosine squared x plus 2 cosine x minus 1 cosine x minus 1. That's still equal to 0. So if I factor by grouping, what could I factor out the first 2, John? And what's going to be left after I factor out 2 cosine x? And then what could I factor out of the negative 1 cosine x minus 1? Anna? What can I factor out of these? Negative 1, and I'll have left cosine x plus 1. Since I have the same thing in parentheses, I can rewrite that 1 time, so I have cosine x plus 1 times 2 cosine x minus 1 equals 0. Agreed? Do you know what to do next? Set them each equal to 0. And solve. Did this just say solve, or did this say solve over the interval from 0 to 2 pi? All right, so that means I'm going to let you finish this one so we can move on to other problems. Dot, dot, dot. You're going to finish this one off, set them each equal to 0, and generalize your answers. Okay? All right, so let's move on to another one. Not that, not that, not that. All right, let's try this one, except we're not sketching, so let me do this. Okay, so use a double angle formula to rewrite g of x equals 3 minus 6 sine squared x. Well, if we're trying to use a double angle formula to rewrite, is there anything we could factor out of this first? Okay, so if I factor out 3, Billy, what will be left?
1 minus 2 times squared. X.
All right, does,
Isn't that the same as the one we already learned?
yeah, so
Is
what's
that how you rewrite like cosine?
So 1 minus 2 sine squared x is one of our double angle formulas for cosine, right? So that means really I could rewrite this as cosine of what? Cosine, yes, cosine 2x, and don't forget I still have this 3 out front, right? And so I just, this is it, that's all you have to do for this problem. All right, okay, let's take a look at the next one. Is this on your gift? Okay, so, all right, so sine of u is equal to 3/5, and u is between 0 and pi over 2, and I'm asking you to find sine of 2u, cosine 2u, tangent of 2u. Can we just say, oh, sine of u is 3/5, so sine of 2u must be 2 times 3/5, that's 6/5?
No.
No, get onto that, all right?
It's not just a no, that's a no!
All right, good. So at this point, my suggestion is that we draw a triangle in the correct quadrant. What quadrant are we in?
No? Yeah.
Quadrant 1. So I'm going to draw my triangle like this. All right, I'm still having people draw their triangles incorrectly. Start at the origin, draw into the quadrant that you want to be in, and then drop a vertical segment to get to the x-axis. That's the same process all the time. So this is my angle Q, and if the sine is 3/5, I know which side should be 3, which side should be 5. Billy,
Opposite should be 3 and minus should be 5.
everybody agree?
Which makes the other side 4.
Okay, so we've got a 3, 4, 5 triangle here in quadrant 1, and now if I want to find the sine of 2u, let's use our formula for sine of 2u, which is here, 2 sine u cosine u. So I already know sine u is 3/5. What's the cosine of u?
Two hands raised. Just for you.
Really?
4/5.
4/5, because that's the adjacent over hypotenuse. All right, so I got 2 times 3/5 times 4/5 is going to be my answer. So that's really, think of that as 2 over 1. I get 6 times 4, 24 25ths. Does this look okay? So that means that the sine of 2u is equal to 24 25ths. All right. Now that we have sine of 2u, you really could use like sine squared of 2u plus cosine squared of 2u equals 1, right? You could find cosine 2u that way. Or we could actually use one of our formulas for cosine of 2u. For example, we could just use the one that involves sine only, because we were given sine. So 1 minus 2 sine squared, for example. I'm just making up one, but you could really use any of them that you want. So I'm going to do 1 minus 2 times, what was my sine of u?
24 fingers. Nope.
Just sine of u, not sine of 2u. 3/5, but I would have to square that 3/5 down, correct? So I'm going to get 1 minus 2 times, what is that, 9 over 25? Does that look okay?
Yes.
And so I've got 1 minus 18 25ths. That's 25 25ths minus 18 25ths leaves me with 7 25ths. Does this look okay? So that's my answer for the cosine of 2u. Is this okay? All right, now we could use a formula for tangent of 2u.
Yeah, we can.
But can't we just, go ahead.
Tommy's got it.
Tommy?
Can we just put the sine of 2u?
Sure can. So let's do tangent of 2u, because we've already found, sine of 2u, and we found cosine of 2u. We can't take the reciprocals and do 24 25ths divided by 7 25ths. That's 24 25ths times 25 over 7. Are we getting 24 sevenths?
Correct.
Are we okay with this?
So
All right, I don't think I have this one on your paper, do I? We're skipping that one. We're not going to do, I'm sorry to disappoint you, but we are not doing power reducing formulas, but we are doing half angle formulas. So you should get these in your notes. They are where my half angle formulas are right here. Here's sine of u over 2 formula, cosine of u over 2, and tangent of u over 2. Billy.
Why can't we do what we've been doing before and just convert it to u, and then at the end multiply what you get by 2? Remember in section 5.4,
Yeah?
we would just change that part to just u and then find the sine of u, and then convert it back.
That will work for some, but it won't work for everything. So these formulas here,
I was just curious.
yeah, I hear what you're saying, because that does work sometimes. Okay, by the way, you notice that these have a plus or minus, right? Yep, plus or minus on these formulas. The plus or the minus, the signs, S-I-G-N-S, of sine of u over 2 and cosine of u over 2 depend on the quadrant in which u over 2 lies. All right, so let's try this one. Is this one on your sheet?
Oh, will you go back up so you can have that?
Are we okay with that?
We go back to the formula for sine.
Oh, yeah.
I don't know.
Okay, so if we want to find the exact value of cosine of 105 degrees, is 105 on your unit circle? No, not one of the ones that we've memorized. Is 2 times 105 on your unit circle? Okay, so in other words, if I said that 105 times 2 is equal to 210, and 210 is on the circle, right, on unit circle, right, that means that I really could find the cosine of 105 by thinking of it as the cosine of 210 over 2. You see where I'm going with this? That means I'm going to say that 210 is my u, right? If I'm trying to find cosine of 105, I'm really going to think of it as cosine of 210 over 2, where u is equal to 210. So in my formula for cosine, which I have right up here, it is plus or minus square root of 1 plus, what am I going to write? Cosine of 210? Cosine of 210 over 2. Agreed? So with this in mind, I'm going to have plus or minus square root of 1 plus, where is 210?
It's negative 3.
210 is right here, about 30 degrees past pi. So that is the ordered pair. This is 210. And so this is what? Negative square root of 3 over 2, negative 1/2. Agreed? I want the cosine, so is that negative square root of 3 over 2? This is over 2. Does this look okay? All right, and so cleaning this up a little bit, I can get a common denominator. I can write 1 as 2 over 2. And I've got a plus and negative, so I'm going to write as minus square root of 3 over 2, all over 2. How we doing? Okay? And then I can write this as plus minus square root of 2 minus square root of 3 over 2. And this is over, I can think of this as 2 over 1, so this is over 2 over 1. Does that look okay? And then I can rewrite this as plus or minus square root of 2 minus square root of 3 over 2 times the reciprocal of that denominator. So that's times 1/2. And so now I've got plus or minus square root of 2 minus square root of 3 over 4. And now the square root of 4 is just 2. So can I write it like this? Does that look okay? All right, now I've been carrying this plus or minus through this whole time. But remember, the sign, S-I-G-N, right, positive or negative, of my answer depends on what quadrant we're in. This is actually our value for cosine of what? Cosine of 105. What quadrant is 105 degrees in? Now, 105 is going to be here somewhere, right? This is 105. So is the cosine positive or negative in quadrant 2?
Negative.
It's negative, so that means my answer should be negative. Does that make sense? All right. Questions on this? Pardon?
Magnets.
Okay, so let's see what's next. Do you have this one? No? I think I might have cut that one. Oh, that's not nice. All right, looks like that's it. That's it. No, that's it. No, we're not. All right, let's try the next one. The next one is to rewrite sine 5 theta cosine 3 theta. Rewrite as a, what's it say? As a sum or difference, because right now it's a product, right? We've got two things being multiplied together. We want to rewrite it as a sum or difference. So which of these formulas that we have up here are we going to use?
Well,
Which color paper do you like?
red. Not red. Red. Not red. Not red. That part. Maybe Tommy.
Which one?
Maybe white.
I'm going with this one. Right here. People that are watching the video can't see, but that's the one where we have a formula for sine of something times cosine of something, right? So we want to use this one right here. Third one down with me. So I want, read that to me, sine u cosine v equals
1/2.
1/2 sine v cos
u plus v plus sine v.
like this, close bracket. Does this look okay? All right. And okay, so at this point, our u that we're using, u is really 5 theta, and the v is really 3 theta. Everybody agree? So we're going to plug in sine of 5 theta plus 3 theta plus sine of what? Jackie? 5 theta minus 3 theta. Close bracket. And so now we just have to simplify this a little bit, and we'll have our answer. So this is going to be 1/2 times sine of sine of 8 theta plus sine of, is this 2 theta?
Yeah.
Does this look okay? All right, so yeah, I think that's about it.
Wait.
That's it. Okay.
I know that all my
How did you get to that point?
I know that all my homework is
Well, what we did, Billy, we recognized that we wanted to rewrite something that was a product as a sum. So we're going to go from the product to sum formulas, which are here. Product to sum formulas are here. Because these are products on this side, and we're rewriting them as a sum or difference over here. Does that make sense? Just plug in 5 theta for you and
I
gotcha. Okay, so let's see. Let's take a look at number 6. It says find the exact value of sine of 195 plus sine of 105. Sine of 195 5 cosine of 105. Okay, if we want the exact value, no fair plugging this into your calculator, right? We want the exact value. Which formulas would we want to use now? What color sheet are we talking about? The purple sheet? Does that have our sum to product form? Yeah. All right, so let's use this. Number 1. All right, so it says, so the formula says sine u plus sine v equals what? Times? Did I get that copy down correctly?
Yeah, I did good.
Okay, so what am I plugging in for u? What am I plugging in for v? Alright, u is 195, and v is 105. So I'm going to have 2 times sine of 195 plus 105 over 2 times cosine of 195 minus 105 over 2. Does that look okay?
See where you're going with this one.
What's 195 plus 105?
300.
300. So I get 2 sine of 300 over 2 times cosine of, what's 195 minus 105? 90 over 2. So I have 2 times sine of 150 times the cosine of 45. And really, I'm not going to leave it like this, or we could find, and we're trying, well, actually not, I actually would not leave it like that, because weren't we asked to find the exact value?
Of course we were.
So let's keep going. 6 times cosine of 45. So I get 2 times, what's the sine of 150 degrees? 150 is right here. That one here is. So this is 2 times 1/2, and cosine of 45 is here. So that's square root of 2 over 2. Agree?
Game over. That's the answer. Circle it.
2's divide out here, so do I just get square root of 2 over 2?
Yes.
I'll be okay with this.
Over.
Alright. Okay.
That's just why don't we just put an exclamation on the head instead of the gang?
Because it's annoying to have them on my ears. That's why. Okay, so let's take a look at, I think I want to skip down to number 9,
I don't like that.
because I want to get to this projectile problem. Okay, ignoring air resistance. The range of projectile fired at an angle theta with the horizontal and with an initial velocity of v sub 0 feet per second is given by r equaling 1/16 v sub 0 squared sine theta cosine theta, where r is the horizontal distance in feet that the projectile will travel. A place kicker for a football team can kick a football from ground level with an initial velocity of 78 feet per second. At what angle must the player kick the football so it travels 188 feet? All right, this formula for projectile model, what was it, 1/16? Is that right? V sub 0 squared sine theta cosine. Squared sine theta cosine theta. So what can we plug in with?
R188.
All right, we want it to travel 188, so that's the range, so that's going to be here. 116. Do we know the initial velocity?
It was called
Yeah, 78 feet per second.
All right, so that's 78, and we're going to need to square that times sine theta cosine theta. Are we trying to solve for theta? Yes. Okay, so here's the suggestion. We probably don't want to solve if we got 2 different trig functions. That makes it difficult. So what you could do is, let's multiply, let's multiply both sides of the equation by 2. reason I'm suggesting that we do that is because don't we have a formula for 2 times sine of theta cosine theta?
Do we?
What is
Yeah,
it?
we do, yeah.
I know, there's so many
Sine
formulas, it's hard to keep them all straight. All right, so we can write this as sine of 2u, agree? So I now have, what's 2 times 188?
Now,
376 equals 1/16 times 78 squared times sine of 2u. So at this point, help me out, let's multiply both sides by 16. What's 376 times 16?
why would we, oh, yeah. Oh, you wanted us to do that?
I'm holding the smartboard marker and the headphones. I cannot resolve the calculator.
That was the super smart. I knew you
Was
wanted
it?
to do it.
6,016.
6,016?
6,016.
Is that then equal to 78 squared times sine of 2u? 78 squared times sine 2u. All right, so go ahead and divide both sides by 78 squared.
Figure out.
78 squared. 6,000.
I'm only interested in your final number for sine of 2u. It's going to be some nice decimal.
Step 0.98888.
What is it? 0.98233? You people agree with that?
Oh, we're dividing.
What? Yes? Do we have independent calculation of this?
Yeah.
0.98833.
0.98,
3 eighths. I got 3 eighths. And then 2
.9888,
3.
23?
2314.
Okay, so,
Let's do it 1
everybody agree on this? Yes? Okay, so at this point, if that's sine of 2u, let's make a little substitution. Let's let w equal 2u. So that means that the sine of w is equal to 0.9888314, right?
So we use the arc sine formula.
All right, thank you, Billy. That means that the arc
W equals the arc sine of 0.988.
arc sine of 0.9882314 is going to be equal to W.
I thought, no, you
Calculator, please.
you missed it. You missed it. You missed it.
Missed an 8?
How can you miss those single 8?
Does that look better?
There you go.
What do you get?
I didn't do it yet. Really? That's it.
81.42, 56, right, I'm going to round to 81.43. What units are we talking about?
Right.
Degrees?
I didn't get that at all.
This is degrees? Do people agree? Can we have independent confirmation?
Do we want
Well, we do want our angle expressed in terms of degrees, so if your calculator is giving you radians, please convert.
We'll talk about 180 over 5.
Are we agreeing? So, final step, don't forget that this is really 2u, so you're going to have to divide both sides by 2. And so it looks like the angle that we're supposed to be
40.712 degrees.
40.71 degrees. Does this look okay? Something like this? Whatever it is. All right, so you're going to check the web page for the homework. I'm going to have you try some homework tasks from section 5.5, and I'll have you finish this vehicle also. Oh, and we got to add this. Quiz next class on 5.
4, 5,
5, 3.
5, 3. Just 5, 3.
Please just 5, 3.
Quiz on 5, 3 and 5, 4. Thank you so much. Thank you, everybody, for getting my way. Do I have one more trophy out there?
I think I may have one. I see it.
And that's it for this video. As Mr. McBrayer would say, signing out.